If you hold a shell to your ear, you hear something that sounds like the ocean, but really it's just molecules moving through the air and bouncing around in the shell, which funnels the sound. The ear is also a sound funnel. It is made up of the helix, the globule, and together they make up the auricle. Sound travels through the air filled with molecules pushing each other in waves of sound. Here is the outer ear and the ear canal that stretches out to the tympanic membrane, also known as the eardrum. The eardrum is connected to 3 tiny bones which articulate with a spiral-shaped organ that looks like a snail called the cochlea. There are 2 nerves that stretch out from the cochlea called the vestibular cochlear nerves. The anatomy of the ear is divided into 3 sections: the external ear, the middle ear, and the inner ear. The middle ear are more specifically called the auditory ossicles, which include the tympanic membrane, the 3 tiny bones called the malleus, which is attached to the tympanic membrane, the incus is in the middle, and the stapes, which looks like a potato masher, touches the cochlea. Then there is the tensor tympani muscle and the stapedius muscle, which help to move the ossicles. And the loopy things that look like slides at the water park are called semicircular canals, which are divided into anterior, posterior, and lateral sections. The tympanic membrane vibrates, making the 3 tiny bones move like a lever system and vibrating against the cochlea. The physiology of hearing. Sound waves funnel through the auricle, causing the eardrum to vibrate. Then the 3 tiny bones move. The stapes vibrates against the oval window, producing fluid pressure waves to travel through the scala vestibuli. Sounds with frequencies below hearing range travel through the helicotrema and do not activate hair cells in the basilar membrane. Sounds high enough for hearing range go through the cochlear duct, vibrating the basilar membrane and activating the hairs on the inner hair cells. Vibration of the basilar membrane pushes hair cells of spiral organ against the tectorial membrane. Hair cells transduce sound energy to graded potentials. Action potentials are released into afferent nerve fibers. The round window bulges, releasing pressure. Here is the image of the organs of Corti, or the spiral organ. Below is the basilar membrane. Vibration of the basilar membrane pushes hair cells of the spiral organ against the tectorial membrane. Hair cells transduce vibration into graded potentials. Action potentials form in afferent nerve fibers. High-frequency sounds displace the basilar membrane near the base. Medium-frequency sounds displace the basilar membrane near the middle. Low-frequency sounds displace the basilar membrane near the apex. The auditory pathway to the cortex. Number 1. Sound funnels and sound waves through the ear. Number 2. The sound is amplified through the vibrating tympanic membrane. Number 3. The cochlea is where transduction of sound occurs, sorting out sound by frequency. Number 4. Vestibular cochlear nerve is activating, sending signals from the cochlea to the brainstem. Number 5. Signals travel through the brain, getting decoded along the way. Number 6. The signal travels to the auditory cortex where it recognizes and processes sound.